Hello guys, in this lecture we're going to talk about a concept used in machine learning when we talk about how well a machine learning model learns and generalizes to new data, namely overfitting and underfitting. In machine learning, we usually try to predict outcomes for values that we have never seen before, based on training data that we have seen. The goal of a good machine learning model is to generalize well from the training data to any data from the problem domain. This allows us to make predictions in the future on data the model have never seen. A model that generalizes well is a model that neither underfitted nor overfitted. Now let's generalize a random dataset and plot it. This is our dataset. Now let's fit a decision tree to our data and plot the results. We see that the classifier is fitted to every single value of our dataset, and that indicates overfitting. So what is overfitting? Overfitting refers to a model that models the training data too well, which means that the model learns the details and noise in the training data. To extend that, it negatively impacts the performance of the model on a new data. This means that the noise in the training data is picked up and learned as concepts by the model, which negatively impacts the model ability to generalize. Overfitting is more likely with non-programmatic and non-linear models that have more flexibility when learning a target function. But many non-programmatic machine learning algorithms also include parameters or technologies to limit and constrain how much detail the model learns. For example, decision trees are non-parametric machine learning algorithm that is very flexible and is subject to overfitting training data. In our code, we did two mistakes that led to overfitting. The first one is we didn't split our data into train and test sets. Instead, we fitted all the data to the classifier, which led the model to learn the details and noise in the training data and prevent the model to generalize. And the second mistake is we have set its max depth to 15, which is very high value corresponding to our small data set. So to avoid overfitting, we can do many things. For example, we can simplify the model by selecting few parameters. For example, linear model rather than a high-degree polynomial model, by reducing the number of attributes in the training data or by constructing the model. A second way to avoid overfitting is to gather more training data. We can also reduce the noise in the training data. For example, by fixing data errors and removing outliers. One efficient way to avoid overfitting is to apply cross-validation, which we will learn in the next video. Now let's run the same code, but this time we will split our dataset to train and test sets, where the train set is only 10% of our data, and we will change the max depth to 1 instead of 15. We see now that the model has underfitted our dataset. So what is underfitting? Underfitting refers to a model that can neither model the training data nor generalize to new data. An underfit machine learning model is not suitable model and will be obvious as it will have poor performance on the training data. To avoid underfitting, we can select a more powerful model with more parameters, or feeding better features to the learning algorithm, which is known as feature engineering. We can also reduce the constraints on the model. In the next two videos, we will learn how to detect overfitting and underfitting using learning curves and how to avoid them. See you then.